next screen. All right. There's today's objectives. I'll leave them up for a second. Forgot to hit record, so you didn't get the whole reading through this, but I'm sure you'll all survive. All right. So we've already done a point estimate before. We did this in 8.2. It is basically the same thing as when we're doing our experimental probabilities. We're taking the number of successes divided by the total sample size. So whatever characteristic we're looking for and divide it by the sample size. That's the point estimate. It's the same thing we've already done. I'm just reminding you of it. And I don't think we need to actually recalculate them. I'm going to talk about confidence intervals. This is what we're doing today. You've seen them before. If you have seen any kind of data regarding elections for the most, I mean, that's like the biggest place that we see them. You've seen confidence intervals. So it is we usually have confidence intervals when we don't know the population proportion. So it would not make sense to poll an entire population. So we will take a sample and we will construct a confidence interval. So level of confidence is so basically what I'm gonna try to figure out the best way to describe this. So if I were to take, let's say I took a hundred samples of size 25 or whatever. I took 100 samples. The level of confidence is how many confidence intervals I would expect to contain that population proportion. So a confidence interval, we say that as you've seen it in elections and things where it says like this person is projected to win 46% of the vote plus or minus 4%. So somebody did a poll somewhere and 45% of the people said, I'm going to vote for this person, but you have to have that margin of error, that plus or minus whatever percent. You have to have that because we haven't polled the entire population. So our level of confidence, so if I said I had a 98% level of confidence, I say I'm 98% sure that this person has 45% of the votes, plus or minus 3%. Then if I took 20 or 100 different polls, 98 of them would contain the actual population proportion. We're going to see a little bit of that more as we keep going once we start doing our math. So the level of confidence is how many of those confidence intervals would contain your actual parameter of interest. All right. So, oh, this is right here. So for example, 95% level of confidence tells us that if 100 different confidence intervals are constructed, everyone is going to be a different sample. We'd expect 95 of them to have our parameter of interest. 5 of them would not have the parameter of interest. And we're going to be giving you the confidence level, sorry. I'm not going to ask you to come up with that unless you are doing it with your final project. Then obviously you're going to come up with your own. 95% is pretty common. Sometimes they'll do 99%, but 95% is fairly common. All right. This is what one of the ways that our confidence interval looks like. So you would take your point estimate, which of course is the number of successes divided by your sample size, and it would be plus the margin of error and minus the margin of error. So if it was 45% with a margin of error of 3%, it'd be 45% plus 3% and 45% minus 3%. That's why we have that plus or minus in there because you're both adding and subtracting that 3%. So this tells us how accurate our point estimate is. It is so in this case, our confidence interval would go down to 42, which is 3 below the 45%, to 48, which is 3 above the 45%. So basically, I'd be like, I'm 95% confident that the actual percent of people that voted for this person is between 42% and 48%. This is how we do a confidence interval. We're going to be doing all the math. Hopefully, it'll make sense as we keep going. All right. So these are the 3 things that help determine our margin of error. how confident we are. The level of confidence increases. So as I get a higher confidence level, my margin of error is going to get bigger. Sample size also. So a bigger sample size is going to result in a smaller margin of error because bigger sample sizes tend to be more accurate. So I would have a smaller margin of error. The standard deviation of the population. The more spread out your population is, the wider your confidence interval is going to be. So a bigger standard deviation means your population is spread out more. Therefore, we're going to have um, a larger margin of error. All right. So these are all the things that we're looking at. Let's get to some math. As a reminder, um, for if we have a simple random sample, our mean, let me make sure I have a pen on. Ooh. Our mean is going to be whatever the population proportion is or whatever our p hat is. So we're going to use our p hat for our mean. The standard deviation, this is the same way that we calculated it in the last section. It's the square root of, stop it, square root of p times 1 minus p divided by n. This is the same standard deviation that we were using. And this right here, the NP times 1 minus P greater than or equal to 10, tells us if our sampling distribution is normal. So these are the things that we check along with independence. So if our sample size is less than 5% of the population, then then each trial is independent. All of this stands from chapter 8. Okay. So this is how we are calculating our confidence intervals. This is how we're calculating our margin of error. So this right here is our p hat. This is what we're using as our mean. So this is what we're going to use as our mu sub p hat. That's what we're going to use there. And this right here, all of this, all of this is our margin of error. And it looks really confusing, but it's really not that bad. Let me explain what we're doing. So confidence intervals deal with the center of our data. So we've already kind of looked at this. So if I have a 95% confidence interval that I'm building, then we're looking at the center 95% of our curve. Therefore, there's 2.5% up here, and there's 2.5% down here. So this is something we've already been dealing with, where we're looking at the center of our data. That's why this right here, I'm going to erase some of this. This z-score says z sub alpha divided by 2, which alpha is the space remaining right here. So that 5% remaining, we're dividing it in half. So our z-score is going to be based on the half of what's left, so 2.5% that's left. So that's what the z-score is based on. We're only going to use the positive z-scores for these, and I'm going to show you where to find them in a minute. You can use your inverse norm to get the z-scores. It's absolutely okay. But there's also a little cheat sheet on the bottom of your z-table for the basic numbers. So we have our z-score. We're just taking the z-score and multiplying it by the standard deviation. Because we're saying that, for example, if I'm, remember that our middle 95%, that is basically 2 standard deviations away, that was an estimate for the empirical rule. So, but it is actually 1.96 standard deviations away when we're getting exact. So I'm taking that 1.96 and multiplying it by the standard deviation to get what that data value is at the edge of my confidence interval. So our top value is you take the p hat and you add the standard deviation times the z-score, and that'll give you the top value. The bottom value, you take the z-score and multiply it by the standard deviations and subtract it from the p-hat, and it'll give you that bottom value. It's going to make a lot more sense once we're actually mathing it out. I'm just going to leave that there. Right. Let's move on to actual math. This is the same, basically the same diagram I just drew, but maybe it's prettier. That z score that we find, this z sub alpha divided by 2, we call it a critical value. It's important that you know that it's called a critical value because we're going to use that in chapter 10 as well. So that's critical value. What it means is that's how far we can get away from the mean and still be inside our confidence interval. So we can be 1.96 standard deviations away or 2.45 standard deviations away or whatever it ends up being. That's our critical value. Let me show you where we find those.
So when it says from the param or sample statistic can be from the parameter, it means like from the mean.
Yeah.
Okay.
So yes. So the from the mean from that p hat that we're using, yes. So it tells you how far it can be away from there.
Okay.
Yeah. Okay, I'm going to go to my Z table. At the bottom of your Z table, you may have noticed this before and wondered what the heck it was talking about. These are the most common critical values we use for confidence intervals. So you're not going to have to do any of your own math if you get one of these. So if you are looking at a 95% confidence interval, we have our 95% right there, and our Z score we're using is 1.96. Or if you are looking at a 99% confidence interval, then you're going to have a Z score of 2.575. These are the most common. Occasionally, my open math will throw you a curveball and decide to give you some really weird confidence level. It'll say something like 85% or 80%. If it does that, you're going to have to use your inverse norm to get your value. So I'm going to show you real quick. We've done this before, but I want to make sure that you remember. So let me give some space. I'm just going to do it right here. All right. So let's say that they gave you 80%. So I'm going to go right there and I'm going to draw this. So this is really poorly drawn, but this is if they give you 80%, then what's left, 1 minus 0.80 equals 20%. And then I divide that by 2. And I know you can do this in your head, but this is good for notes. So I have 10% here, and I have 10% down here. So when I do inverse norm, I'm going to do inverse norm 0.901. Because it is 10% from the top, I'm going to put 0.9 in there. If you accidentally put 0.10, it's okay as long as you change your z-score to a positive number. Our z-scores are always positive on this. So once you have that, that is your z sub alpha divided by 2. That's that z-score. And we would have, I don't know, let me see what that is. I don't know that one off the top of my head. So it'd be 1.28. So you would use 1.28 as your z-score in that case. So, but my open math mostly sticks with these ones, but every once in a while it decides to throw a curveball. I can tell you that on the test, I know we just had a test, but when we get to the next test, I'm only going to use these ones. I'm not going to use anything fancy because out in the wild, I've never seen them use something different. One thing that really annoys me out in the wild is that they don't tell you what your level of confidence is. So when they're making these, it's 45% plus or minus 3%. For all we know, could be a 20% confidence interval. You're welcome, Kate. I mean, we don't know what their confidence level is. We don't know. They don't tell us, so it could be anything. So that's why polls, I kind of take them with a grain of salt because they don't tell us. They don't say we're 99% confident. They don't say we're 90% confident. For all we know, it's 25% confidence. Who even knows? So if they don't tell us, I mean, I'm sure that there's probably um, something published somewhere, but it's still, you can't trust everything you see on TV. I know y'all know that. You're all smart enough to know that. All right. So our interpretation, this is a lot of words. We could say something like, I don't even like this. It just basically says, so if I had a 95% confidence interval, would indicate that 95% of all of my samples of the same size would result in the interval that contains the parameter. So what we're saying is that I am 95% confident that the actual population proportion is within my confidence interval because we're estimating what the actual value is because we don't know that. So we're estimating the actual population proportion. Right. All right, we can math. Woohoo. Okay, good. I like it when we get to the math. Okay. So in July of 2008, a Quinnipiac University poll asked 1783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1123 were in favor. We're going to obtain a 90% confidence interval for the proportion of registered voters who are in favor of the death penalty. Okay, so the first thing I'm going to do is I'm going to find my p hat. So I'm going to put it up here because this is going to be my working area up there. So the p hat is 1123 over 1783, and I'm going to get an approximate value there. So I'm going to put 0.63, so about 63%. I'm just going to, so 1783 is less than 5% of my population, is less than 0.5 of my population. Now we want to do NP times 1 minus P. So 1783 times 0.63 times 1 minus 0.63. We need to see if this is greater than or equal to 10. Oh man, it's 415. I think we're good. What do you think? Think we might be okay. That is greater than or equal to 10. Okay, so I checked those things. All right, now that I have my p hat, the way that I do this is I generally do it one piece at a time and then put it all together. I don't like doing all the math at once because I like to understand what's going on. You can do all the math at once, but I like to know what's going on. The first thing I'm going to do now is I'm going to go to my z table. I'm going to look at the z sub alpha divided by 2. This is my critical value. Critical value. Critical value is going to carry us through chapter 10 also. So I'm going to try to keep using that vocabulary so it's in your noggin. We are looking for a 90% confidence interval. So over here, 90% gives us a z-score of 1.645. So notice right here, 90%, 1.645. So 1.645. Now I'm going to calculate the standard deviation. So it's sigma sub p hat square root of p, which is 0.63, 1 minus p divided by our sample size. I'm going to calculate that. I'll put it down here. If you're careful with your parentheses, you absolutely can do this all at once in your calculator. If you are not careful with your parentheses, then do it a piece at a time. Right. Approximately 0.011. I don't like that. I'm going to try it again. Is that right? It looks like it's right. I'm dividing by a very, oh, I didn't take the square root. No, I did. I'm dividing by a very large number, so that would make sense. So this right here is my standard deviation. Sample size makes that number a lot smaller. Yeah, that's correct. Okay. All right. So that's my standard deviation. So now I'm going to take my p hat and I'm going to add the z-score, uh-oh, z sub alpha divided by 2 times our sigma sub p hat. So I'm going to take, actually, not doing that yet. Let's calculate our margin of error. It's going to make it a little bit easier. I'm going to calculate the margin of error. So my margin of error is z sub our z-score times our standard deviation. So it's the z sub alpha divided by 2 times sigma sub p hat. So our margin of error is going to be 1.645. That's really ugly. Plus or times 0.11. Okay. I'm just going to use the number that I already have in my calculator. 1.645 times the previous answer. So my margin of error is now, I know that I've always been a stickler for not rounding so super early, but pretty much it's standard to just round to two decimal places. So we would just say that our margin of error is 2%. It's pretty standard to round the margin of error like that. Now my open math has a mind of its own, but I'm telling you for purposes for me, margin of error, generally, we just round it to two decimal places. So the actual is 0.0188. So I just rounded it to 2%. So here's how I would write this. There's two different ways that you can write your answer. I could write my answer as my p hat 0.63 plus or minus 0.02. This is one way to write this. So this right here is the p hat plus or minus, plus or minus my margin of error. That is one way to write it. The other way to write it is like this. Let me see here. So I would take my p hat, my 0.63, and add the 0.02, and that's 0.65. I'll take the 0.63 and subtract my margin of error, 0.61. And I kind of ran out of room, but I'm going to do the best I can to write my conclusion here. Okay. Whoa. And I'm going to, yeah, okay. I'm going to write it in, find a different color. Let's just do black. We are 90% confident that the actual proportion of people, of voters in favor of the death penalty is between 0.61 and 0.65. And you're welcome to say between 61 and 65%. I don't care how you do it. My open math will care. I don't care. You could say the actual proportion of voters in favor of the death penalty is 0.63 plus or minus 0.02. That's fine. You could even say 63% plus or minus 2%. I'm okay with that. I'm also okay with you saying is between 0.61 and 0.65. As long as it's there, you put it in the terms that are make sense to you. Questions on this before we jump to the printed portion? where they did all their stuff. Okay. And they didn't even, the math, I, yeah, I lost their math, but they did the exact same thing we did here. They did their NP times 1 minus P. They checked their sample size. They did all of the same stuff we did. And for some reason, their math has disappeared. So it's a good thing I did the math. But here's the conclusion. The conclusion is the important part right here. This is basically the same thing. We are 90% confident the proportion of registered voters who are in favor of the death penalty for those convicted of murder is between 61 and 65%. So I know this is a lot of words, but this is what conclusions look like. This is what they look like. This is basically what we're expecting. All right, ready to move on to another one? It's not too shabby.
I'm still not understanding how you obtain the 90% confidence part.
They gave it to us right here.
Okay.
Yeah, they just told us. And that's what they're going to do. They're just going to tell you what they want. They're just going to say, give me a 90% confidence interval.
Okay.
You're not going to be making it up on your own. Is that what you're asking, or were you looking for the Z-score part?
Yeah, like I don't know. I guess I don't know. I'm still a little lost if I'm being honest, but that's okay. I'm just gonna rewatch the videos a couple more times and
Okay,
read the
so
textbook.
they're going to tell you the 90% confidence interval. So basically what's happening is I don't want to lose you. So they have this right here is where I got the critical value.
Oh, okay. Okay.
Yeah. So basically it's like what's happening is if this was 90%, so the middle 90% is right here. This is the middle 90%. So there's 5% below and 5% above. So if I put into my calculator inverse norm with 95%, I'm not going to put all the rest of it. I will, but it's not going to fit well. I would get that 1.645. They're just giving it to us.
Okay.
So basically, somebody just did inverse norm for us. That's where the Z-score came from.
Okay. Got it. Thank
Are
you.
we're good? Okay.
Yes, thank you.
I don't want to leave anybody behind. I'm sure there's somebody else in this Zoom meeting or somebody watching the video that has the exact same question. So I don't, I, th that was really good. Thank you for stopping me.
Yeah, I normally read the textbook and watch the videos that you provide first so that I have a little bit more comprehension before class, but I just haven't had time this week. So, but
I
thank you.
understand. No problem at all. No problem at all. All right. We're going to do another one. Okay. So a Gallup organization conducted a poll, simple random sample of 1,016 Americans 18 and older were asked, do you consider the amount of federal tax you have to pay is fair? 558 of those adults said yes. Now, we're going to do this one, and then I'm going to show you a fancy calculator function. And y'all are going to be so happy. Maybe some of you don't like calculator functions. I noticed that, especially grading the tests. I can tell some of y'all don't like the calculator functions, but I bet it's nice to know they're there if you decided you did like them. Even if you don't like them, it's not probably comforting to know they exist. So you're going to keep getting them. All right. So I'm not going to do the NP 1 minus P or the 5% of the population. Just trust me on that. I just don't want to do that. But I am going to calculate the P hat. So P hat equals, we just do our 558 said yes out of 1,016. Um, so we're just going to call this 55%. And once again, we just round these to two decimal places. It it doesn't, I don't know why that has become the norm, but it is. We just go with 55%. Technically, it'd be 54.92%, but 55% is just fine. Because, the American public or anybody people don't want to see. They don't want to see you giving that super, super specific. All right. So now let's calculate our standard, or actually, let's find our z-score first. So right here it says we are conducting a 95% confidence interval. So we're going to get our critical value. Z sub alpha divided by 2 equals, let's bop over to here, 95%. We're at 1.96. That's the critical value that we're looking at. Bop back over. All right. You are more than welcome to do the math all at once rather than doing it piece by piece. For some reason, it all just makes more sense to me doing piece by piece. That's why I do it that way. So I'm going to do sigma sub p hat, square root of our p is 0.55, 1 minus 0.55, divided by our sample size, which is 1016. Hmm. I'm going to go to I I know technically it's kind of like 2%, but I don't like that because it's not quite close enough to 2%. So I'm going to do 1.016 because I'm not happy with putting that all the way to 2%. So I'm just going to make it 1.6%. If it was 0.18, I'd feel comfortable with it, but this just doesn't feel close enough to me. So I'm going to leave it right there. All right. So now I'm going to do the margin of error all by itself. So remember, our margin of error is the z-score, alpha divided by 2 times sigma sub p hat. So it's going to be 1.96 times 0.016. This is how we're going to get our margin of error. Times 0.016, enter. Okay, this is a nice 3%. I'm comfortable with this one being 3%. Wonder if it would have made a difference if I'd have changed that. I don't know. I'm not going to play with it. All right. Okay. So this is our margin of error. Once again, you can answer it either, I don't want that color, p hat plus or minus your margin of error so that it would be 0.55 plus or minus 0.03, or we would do, this would be the lower upper. So it would be, we'd take 3% from the 55, 0.52, add 3% to the 55, 0.58. These are the two ways that you can write it, depending on how you want your summary to look. My open math will have both of them. Now, super important, make sure when you're doing when you're doing it like, hold on. Make sure when you're doing it like this one right here, the lower than the upper, that you're putting it in parentheses. There's a few times when people have emailed me that this isn't working and they just forgot the parentheses. And my open math's not always super clear. So I just want to say, make sure you put the parentheses. I'm going to write the conclusion and then I'm going to show you the fancy calculator function. Oh, that is not a pen. I'm not going to do it like that. Okay. We are 90, well, 95% confident that the actual, my writing is terrible, proportion um, of Americans who consider the amount, I'm going to shorten this. Rebecca, I'll get to you let me do this and then I will just a second and I will help you. I will answer your question. The amount of income tax they pay to be fair is between, I'm going to write a little different this time, 52% and 58%. We are 95% confident the actual proportion of Americans who consider the amount of income tax they pay to be fair is between 52% and 58%. So that gives us that margin of error. Before I answer Rebecca's questions, are any other questions here about this specific? And I am going to answer you, Rebecca. All right, I'm going to try to pop to a better screen here. Okay, I'm just going to go back to this screen right here. Okay, so for an 82%, I'm going to draw the picture again. Hey, that one's not bad. Okay, I'm going to draw because this is what I do. 82% in here. So I would do 1 minus 0.82. That's going to give me 18. Take the 0.18 and divide it by 2. So I have 9% up here and 9% down here. So 9% from 100 is 91%. So I'm going to do inverse norm with 0.91. And this is going to give me the 82% confidence interval, or the z-score anyway. So that gives me that critical value, and that's the critical value that you would do. So your z sub alpha divided by 2 would be given to you by that. Does that make sense? Okay, good. All right. You ready for a calculator function? Here it is right here. Write this down. That was ugly. I want to make it prettier. Let's do this. There we go. Write this down. 1 prop z interval. We're going to do this exact question with 1 prop z int, and then I'm going to give you a couple of helpful hints. So 1 prop z interval. All right. Pop over to my calculator. So where you find 1 prop z interval, we are not using distributions. This is not a distribution. So it is in our, remember where we found one variable statistics, where we found one var stats, that's where we're going. Click on your stat button, the stat button right there. We haven't done that in a little while. And go over to tests. Arrow over till you get to tests. We're going to scroll down quite a bit. On mine, it is an A. It could be different on yours. 1 prop Z, it is an A on mine. So I'm going to hit enter. And in a minute, I think if you don't have this screen, I think it's going to show what it looks like. I don't know if it shows what it looks like or not. Anyway, so our X value is the number of successes. So I'm going to put 558 because 558 people said they considered their income taxes to be fair. Go down to the N. N is 1,016. And our confidence level is 95%. So number of successes, our sample size, and then confidence level. I'm going to hit calculate. What this gives me, it gives me the p hat, and it gives you your lower and your upper. We got 52% and 58%. This is exactly what they have here. Yes, they went out more decimal places than we did, but that's okay. But this gives you the upper bound, the lower bound, and your p hat. So if you needed to find the margin of error at this, if they want you to answer it as p hat plus or minus, I'm going to write this down and then I'm going to show you exactly. I'm pretty sure you probably could figure it out, but sometimes especially in the evenings, it's hard to have the brain power in the evenings. I have this trouble all the time where after I've been teaching all day or after you're at any job all day or with your kids all day, there's not a whole lot of brain power left sometimes. I have so much respect and admiration for y'all taking evening classes. All right, I'm going to pop back over to my other screen. So they might give you this and ask you to write it as P plus or minus margin of error. Now, my open math will do this to you, and you might not even have the P hat. So I'm going to pretend we don't even have the P hat. They will give you that and say, write this as P plus or minus margin of error. Since both of these values are an equidistance from our P hat, if you take the 0.51862 plus 0.57981 and divide it by 2, this will give you your P hat. I'm going to just do it in my calculator because I'm not going to do any math that I don't want. I'm not going to have you do math that I don't want to do. Divided by 2, this gives me 0.549, whatever, 215, all that. Okay, so now I have my P hat. That gives me the P hat part. But I still need to find the margin of error. So you can just take this upper, uh-oh, that's not the color I wanted. Take this upper value right here and subtract your P hat from it, and that'll give you the margin of error. So I'm going to take zero, I wish I'd quit doing that. Wish it would just know what I want. 0.57981 and subtract 0.549. I don't need to use all those decimal values, but and I got my margin of error 0.03 with some numbers afterwards. So you just need to do that in order to find that. So just average those two values to get your p hat, and then just take the top value, subtract the p hat from it, and that'll give you your margin of error so that you can do 0.55 plus or minus the 0.03. So there you go. We're going to do another one with the prop Z interval. We're going to do the first one that we did just to make sure we have it. Then I'm going to give you a little bit of a hint. Any questions on this before we do that? Okay. I'm going to go back to the first one. I want you to try this in your calculator without me. I know there's a whole lot of stuff on the screen right now, but go ahead and try this one on your calculator without me. And I'm going to try it on my calculator without you. I know, so rude of me. So prop Z int, stat, and go over to tests. One prop Z int. Don't forget to change your confidence level to 0.9. And check with the answer that's already on your screen, the answer we got before, and see if it matches. How'd we do? Yep, yeah, because we got 0.61 and 0.65. Yeah, good, 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 good. Yay! You did it. All right. So I'm going to jump back to a different screen so I can show you. Maybe I can even get into my open math and help. And I don't know if I can get there quick enough. Sometimes my open math doesn't want to open when y'all are here. Okay. So I'm going to look at 9.1 here and find a question like it. My open math tries to make it so you can't use your calculator, and I'm going to see if I can find a question. Oh, yeah, this one right here. So, that one actually is not too bad. Let me find one here. How come there's not any bad ones? Okay. Of course, I get all the ones with the um, good one here. Okay. Um, so I'm just going to use this example because it might end up with, it's still not going to end up with a bad thing. See, it's 4220 times zero point 0.3, enter. 4220 times zero point 0.3, enter. So sometimes none of these are bad numbers. Sometimes they'll give one that's a percent. So instead of saying like out of 350 people, um, you know, 26 of them had this thing, right? This qualification or whatever. So this right here says 40% are in favor of candidate S. So you're going to need to find out what 40% of 350 is. So you would just do zero point 0.4 times 350 to get your value. So your X would be zero point 0.4 times 350. So it's 140. So you need to calculate that. Now, they gave me all pretty numbers, but it happens sometimes when they will give you numbers that are not pretty. So let's say that um, they did 350 people if they liked dogs, and 6.8%, let's see, said that they did like dogs. Okay, so if I did 6.8% of 350, I would get 23.8. So if you get a number like that, if you are calculating the number of people that say they like dogs, for example, and you get a decimal, you'd have to round to the nearest whole number because prop my one prop C int will not allow decimals. It won't allow it. Your number of successes has to be a whole number. So if, for example, if I got 23.8 when I calculated the percent of people that like dogs, I would just round it to 24. Trust me, it works and it'll still give you the right answer. That my open math is trying to get you to do it all by hand, which is absolutely fine. But if you just round to the nearest whole number, you will still get the correct answer. Okay, let's move on. Go back to where we were. Where were we? Okay. So this is just the margin of error formula. We've already found this. Sometimes you will see it written with a capital E. Sometimes you will see it written as ME. So if it's a capital E, that is still margin of error. Now, when we are calculating a sample size, so let's say that I wanted a margin of error of 3%. I would need to use this formula right here. I need to calculate a sample size. The problem is that all they did here was take our margin of error formula. They took this formula right here and actually, hold on, the whole thing. They took this formula right here and they just used algebra to manipulate it. They solved for n. So that's all it was using algebra to solve for n. And we end up with this. The problem is it requires p hat. With p hat, we have to know what the sample size is. P hat requires us to have a sample size in order to calculate it. So people that are smarter than me had to figure out, what are we going to do? What are we going to do in order to figure out a sample size if we don't have a p hat? There's two different things that we can do. You can use a previous study. So maybe a couple of years earlier, somebody did the same study. Or if you are polling for a presidential race or something like that, be like, okay, well, last week's poll had this person at 35%. So I'm going to use 35% for this. So you're just kind of making a guess based on a previous study. If you don't have a previous study, you're going to use zero point 0.5 as the p hat. Zero point 0.5 will give you the most extreme possible sample size. So it's going to give you like the biggest possible for this thing. It's the largest possible value. You don't want to use zero point 0.5 unless you have to. You're going to see in a minute. We're going to do examples. You're going to see what it looks like with zero point 0.5 and with a previous study. So let's take a look. Let's do some math. This is the formula. All right. That this right here, it shows the formula again with 0.25. Hey, that's kind of funny. This right here is just zero point 0.5 times 1 minus zero point 0.5, which is just zero point 0.5. That's going to equal 0.25. You're welcome to do that, or you're welcome to do the zero point 0.5 minus 1 times 1 minus zero point 0.5. Either way is fine. Okay, let's do this. A sociologist wanted to determine the percentage of residents of America that only speak English at home. What sample size should we use if we want our estimate to be within 3 percentage points and 90% confidence? And they're going to use a previous study that was 82.4%. So our p hat that we're going to be using is going to be 0.824 because that was a previous study. We have a 90% confidence interval. So we're going to go back to our Z table. 90% gives us a Z score 1.645. That's our critical value. Okay. Our margin of error is 0.03. So once again, our formula, N equals P hat, 1 minus P hat, times Z sub alpha divided by 2. Let me do this again. Alpha divided by 2, divided by the margin of error squared. So let's do this. 0.824 times 1 minus 0.824, 1.645 divided by 0.03 squared. If you are careful with your parentheses, put parentheses everywhere I have them. You can put this all in your calculator just as it is. Uh-oh. How come I apparently can't type in my calculator. Once you close the parentheses for the Z score divided by margin of error, then just after you close that parentheses, just hit the X squared button. The answer I got, 436.04. All right, let's stop right here for a second. We can't poll a partial person. I cannot poll 0.04 of a person. And 436 is not big enough. We always round up to the next whole number. Hold on. There we go. Always round up to the next whole number. Even if it's 0.04, always round up to the next whole number. I look at it like this. By law, you can't put more, this is a random number, I'm making it up. By law, you can't put more than 50 children on a bus. I can't put 51 children on a bus. Not allowed. By law, I cannot do that. If I have 202 kids, I have to get the fifth bus. I have to, because I cannot put more than 50 kids on a bus. You have to round up. That's kind of how, that's like the way that I explain it. So always round up to the next whole number. Always, always. No exceptions. I believe it's all printed out right here. All right. Questions on this before we do another one? We're almost done. We have one more problem, and then we're done. All right. Maybe if I can get to the next screen. Oh, there we are. We're there. All right. I'm going to have you do the first one, and then we're going to do it again because we're going to do it with no prior estimates. We're going to do it with a prior estimate. What size sample should be obtained? The economist wants to estimate within 2 percentage points of the true proportion with a 90% confidence if the economist is using a 2009 estimate of 10% from this survey. So remember, this is the formula. And 90% is 1.645. Okay, go for it. I will work quietly behind you. Yes, good. How'd we do? So you need 609 people, or yeah, 609. So now not using any prior estimates, the only thing that changes is this part right here. Not using a prior estimate, that changes to zero point 0.5. So go ahead and try it with the 0.5. So everything else is the same, but that's going to change to zero point 0.5 and 1 minus zero point 0.5. You can change it. You can just do 0.25 if you want, which is what I'm going to do if I get a pen. So go ahead. I'll work quietly behind you. Going to be shocked at how much bigger the number is.
How did you get E, the
Uh,
0.2?
it's because it says, where is it? 2 percentage points.
2 percentage point. Okay.
Yeah. Bet you at least one other person had that same question. Anyone have a number? Yes. Ter Terrible, isn't it? So much more than twice as much. So if you can use a prior estimate, use a prior estimate. Yeah, it more than doubled. It's crazy how much different it is. It's wild. So yes, so the moral of the story is if you can find a prior estimate, use a prior estimate. Any other questions about finding the sample size or anything else? You use the zero point 0.5 and you got the same thing? Good. Good, good, good. Use the zero point 0.5 and 1 minus zero point 0.5. Yeah, good. So if you are building a confidence interval of your own, you don't have to. I've had people do it final projects before. You don't have to. But if you are doing it in your final project, you can look at your own data. And then if you wanted to, you could see, oh, look, There's a study out here that shows that, you know, 58% of people use creamer in their coffee or whatever. And so you can choose one of those if you wanted to build your own confidence interval. It's, the possibilities are almost endless. Whatever you feel you need to do, and you might just want to say, I want to know approximately where the population lies. I mean, sometimes there's many people who've done final projects that they're like, well, this doesn't lead to answering my question, but I was curious. So I performed this type of analysis on it because I was curious. Absolutely fine. Do that. If you're curious, do it. Right. That is all I have. Any questions on the material or anything that you want on the record on the recording? Any questions for on the recording? I think that was it. Yeah, there's nothing on the next page. All right, I'm going to turn off the recording.